Hey there. Let's do a little review of what we've learned the last couple weeks. Just statistical analysis and probability, which we didn't really get to the probability part. Kind of cut that one out for time restraints, but we'll just talk a little bit about it probably tomorrow. All right, let's do a quick review. To find the average, everybody knows this, equals average. Make sure you use the equal sign. At the word average and then start a parenthesis. And we want to find the average of the population of the United States over the last, looks like 17, 18 years. Okay. Hello. Can you go away now? Thank you. Enter. It's not behaving. I've had some issues yesterday. You guys saw that too. 304 million people with a standard deviation of equals STDV. Now I've been doing sample populations for a while. I would argue that this one is a sample as well, because it's not all the years of the United States. So sample, boom. Same data set, enter. 13.1 is the standard deviation. Okay, to answer the next two questions, we have to come over here and kind of lay out the data spread. So start with the mean, 304.1. And to move this direction, we're going to go equals this number plus 13.1 for the standard deviation, and carry that through 2 times 1, 2. Okie doke. Over here, equals the mean minus 13.1, enter. Drag it 2 to the left. Okay, see how easy this is? How many years are within one standard deviation of the mean? Okay, so between 291 and 317.2. So no, 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 no. So we'll start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We'll count the 317 because 317.2. So what I say, 11? There are 11 years where that is true. Is there anybody outside of 2? I highly doubt it, since the standard or the population of the United States goes up about 2 million people per year. It's not like we're going to have in this last year like this huge jump where it just skyrockets. So I just don't see that really happening with this kind of data set that we're dealing with here. So no, just not really possible. How would you describe the increase in the United States population over the last 18 years? I think I just said it. It's been pretty steady. Wouldn't you argue? I mean, just look at the numbers from year to year. The average is 304. That puts it right there in the middle of the data set. And you've got basically plus 3 million, 1 million, 2 million, 3 million. It's pretty steady throughout the years. We haven't had, it's increasing, number one. So going up at a steady pace. Oh, what we got going on here? Show me your end zone dance. That's Kirk Cousins right there. He's a little goofy sometimes. These are the most touchdowns thrown by a quarterback in the particular season that is given from 2008 to 2018. So let's go ahead and lay out our data set. What is the standard deviation of touchdowns? What's the mean? I guess I reversed those two from the one that's up above. You can get rid of Kurt if you don't want to see him. I'm kind of tired of that too. Equals average. Now with this one, we might have something more going on here than we did with the population in the United States, simply because it's not like the number of touchdowns thrown by the quarterback who throws the most each year is just going to go up by 2, go up by 1, go up by 2. There's no guarantee for that. It could fall. It could go up to like 50, as you see here, or 55. There's nothing to indicate which way it's going to go. Okay. So equals standard deviation. Enter 7. All right, so the mean is 41. We're going to add 7 onto that number going this direction. I think I forgot to click it. Here we go, plus 7. Do it that way. Equals my mean minus 7 to this direction. Boom. Now that we've got the data spread, let's answer a couple questions. How many quarterbacks are above 1 sigma? Above 48. Let's see. Peyton Manning, Patrick Mahomes. That's it. That's the list. There are two. You can record their names there if you like. How many quarterbacks are below -1 sigma? So below 34. Well, Drew Brees is at 34 twice. Russell Wilson is at 34. 0. Nobody is that low. Okay, so of those, and based on that data, would you consider any of these quarterbacks on this list superior to the rest? Now, this is based on just one metric, which is throwing touchdowns, which is not the only one that really, I mean, it's how you score points. If you have somebody throwing 55 touchdowns in a season, which is the most all time right there by Peyton Manning, I think he had a pretty good year. Pretty sure he won the MVP. I think they went to the Super Bowl. That was the year he was with the Broncos. Yeah, that's pretty good. So I'd say Peyton, not there. Wrong cell. Peyton is borderline an outlier. Not really. In accordance or according to this data set. I mean, Patrick Mahomes has had a couple of just ridiculous seasons, but to throw 55 touchdowns with this group of Hall of Fame elite quarterbacks on this list, I'm pretty sure every one of these is going to go to the Hall of Fame, except for probably Andrew Luck. He's had some injury problems and he's now retired. Yeah, to be on this list and to be 2 full standard deviations away from the mean, that's pretty darn good, considering the company that you're in. If it was like all the quarterbacks in the NFL, and you lay out all 30 of those, well, there's more than 30, but 30 starters roughly, and then you're like 3 away, it's like, wow, that's just, you're good, man. Pretty good season. Worthy of the accolades. Okay, last one that we're going to do with standard deviation for today. We've got car sales in the United States. Looks like for a certain amount of years. And then US home sales in thousands. Okay, now the car sales are in millions, so that's 8.8 million, keep in mind. And this is in thousands, so that's 877,000 homes sold in the year 2000. Okay, so find the standard deviation for car sales. Just got to make sure you get the right one. Get out of the way, face. Move. There, you go in that big box right there. Let's go sample. Car sales. Enter. What we got? What we got? Standard deviation 0.91 million. And then standard deviation for home sales equals STDV with an S. Show me what you got there. 333,000, because remember that's in thousands. Oh, look at it. What we got here. Go on here. Use Desmos, create a scatter plot, and find the correlation or the R-squared value and place that there. This is going to be real easy to do, kids. You can just open up a blank Desmos document. Okay. I can't do that here because I'm casting my tab. But then you can just put a box around these numbers, these 2 data sets, and hit Control C. Go into the first available input bar in Desmos and Control V or paste, and it'll just put it in a table for you. Okay, and then remember that you got the y1 tilde mx1 plus b in order to get the line of best fit. And once you have that and labeled your x and y axis, of course, I want you to take a snip and put that graph right here. That's going to be done on your own. Okay, so I'm going to come back tomorrow with mine so you can see it. Let's see how you guys do with that as well. Shouldn't be too bad. And then to round out today, you need to answer this question. So it's just curious if you know this or not, but what caused this dip in car and home sales from 2006 to 2001? We haven't even analyzed the data yet, but take a look what's going on here. 7.8 and over a million homes sold. And then it goes down, 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 down. Oof, big drop over those 5 years from a million homes sold down to 300,000. That's a dramatic decrease. And same thing with cars too. Cars took a hit. So not as much, but you can see they went down as well. What happened? Let's get this over with. Go ahead.